Hello, this is Professor Gavor again, and we're continuing on with this model that we've been using, trying to use education or population to predict GDP. And we did the simple linear regression in the first two videos, one just using a graphical method that's the easiest and quickest way to do it in Excel. Then we looked at data analysis where we calculated the analysis of variance using here population, and then you also have the option of putting it on a different sheet. So here's the output on a different sheet. And now we want to look at, well, can we use both? So these methods here are this number, 2461 times population plus this intercept will be what we use to represent GDP. And this one here is 19.432 times education plus 9514.5 to estimate GDP. We see the second model is better because the R squared is higher. It looks like it fits better. The R itself, the Pearson correlation coefficient, is 96.7, which is really high. And it's for the other model, the correlation coefficient was only 45%. In both cases, we saw that if we did the hypothesis test on is there a no regression model or the alternative hypothesis, there is one, and we base it whether we do it on the entire regression or just based on the slope. In the case of the slope, it's the slope equals 0 as a null hypothesis versus slope not equal to 0. Being the alternative hypothesis, we see that both models are significant at least the 0.001 level, with the population model being even more significant. So now let's say, why don't we use education and population? So we'd like to have a number, a coefficient times education number, plus a coefficient times population number to try to predict GDP. And let's see how that looks in this case. So this is multiple linear regression, multiple variables. There's two variables. Notice that the variables are not education and population. It's the multiplier, the coefficient of education and population. So it's still linear in that. So we're going to go to data analysis, and regression. And from the previous ones, we still have the same y variables. But in this case, with the x, we're going to copy education and population. I'm going to highlight all the x variables together. So it goes from B4, which is right here. Well, I didn't mean to do that. It goes from B4 all the way to C43, to C42, sorry. Now I say I want it in a new worksheet. So it's going to make a new worksheet right here. And this is, let's see, what do we call it? ANOVA table GDP and population. GDP versus education and population. Okay, so we see our R squared is also 96. So it's, if we look at the same analysis, it's really good. And our adjusted R squared is very close to that. So really, I think, and I'm sometimes a little naive in this, they're really high in a 90, so you could use either one. We're explaining 96% of the variation here. So if I highlight that in yellow, there we have it. And if we go to our original, we see we had 20 and 93. So we bought ourselves 3 more points in terms of R squared. Now, is there a regression model or not? I'll highlight this F statistic, and the significance again is times 10 to the minus 26. In the previous one, the best we had was 10 to the minus 23rd. So it's even more significant. I mean, it's a crazy good model. So I would conclude that there is a valid regression model here. And if I look at my t-statistics now, and I want to look at both education and population together, I would want to highlight those. And I'm not going to get rid of any of those coefficients because the t-statistic, the t-test, is the coefficient of education 0, null hypothesis, versus not 0. We would conclude not 0. Good. That means we keep it as a predictor. Being 0 would mean it's useless as a predictor. Same thing for population, the multiplier of population. But now we see that education is, the intercept is now a minus 5.559. The education multiplier is 18.3, and the population multiplier is 10.19. I would say this is even better predictor. So let's stick with that. The normal probability plot, we're still not going to get into it yet. But I like the look of the residuals. There seems to be more dispersion around the origin line and very close to the origin line. So it's pretty good versus, and that's for population, using that as a predictor. And for education, it also looks okay to me. There seems to be no discernible pattern of any kind, up or down. It seems to be random error is what we're looking for. So all in all, I would say that this is also a very good model. And which one do you want to use? It really depends what you're trying to predict and how well you're trying to predict it. I guess I would choose, if I was going to try to pick the simplest model I could use, I would use GDP versus education. If I want a little bit more accuracy, perhaps, I would use this model. But they're very, very close in terms of R-squared. I'm just buying a couple points more of explanation. So thank you very much for paying attention, and we'll talk to you again soon. Thank you. Bye-bye.